Hello everyone. Today we are going to discuss different map projections. First, let's discuss why map projections are required. As you know that in GIS everything has to be organized in a GIS database, and you also know that maps represent three-dimensional earth surface into 2D. And when we convert from 3D to 2D, for that we require some system, and that system is nothing but map projections. Map projection itself is a big subject, but I will try to be as brief as possible and should not lose the sight that we are going to use extensively in GIS map projections. Let me first bring a model here. Think that there are longitudes which are going from pole to pole, and there are latitudes, and this is a Bayer mesh, only equator is shown here. So, if we keep a source of light inside this one and put a photographic paper and expose, suppose we put here and expose, then whatever the lines which will come on the surface as radiating lines. But if we keep here, that would be little differently. If we start folding this paper and then expose and then make it flat, then the network or the grid of this latitude longitude is going to be different, and therefore all kinds of complications then come into map projections. Now another very important issue is here that each country on the surface of the globe is located uniquely. Each continent is also located uniquely. And the second important thing is that earth is not perfect spheroid. On the poles you are having some problem, and therefore whenever you use a map projection for a particular country, like say for India, that particular map projection is not going to be suitable for a country which is at higher latitudes, say like a continent like Antarctica. So, if a map projection which is being used for Antarctica, then it is not suitable for India. Another thing, important thing here is that each country would like to represent itself in its true shape. So, if you change the shape, the size of the country will also change. That means the total area of the country. Now, no country would ever like to have that kind of change, and therefore there are hundreds of projections have been developed for different countries. So, now there might be a question, do we have some universal projections? Yes, we are also having some universal projection which we will see little later, but these universal projections are, though the name is universal, but may not be truly universal. So, complications whatever are there we will see. In GIS we have to select a projection. Generally sometimes initially we keep data in geographic coordinates, that is in latitude longitude, and instead of latitude longitude and degree minute seconds, we convert them to DD. This point we have discussed in previous lectures. Then we have to also select a model of the earth, that is the shape of the earth, that is the sphere or ellipsoid, and then we transform these geographic coordinates latitude longitude to a plane coordinates, that is easting northing. In all cases it is not easting northing, but in certain projections we call them an easting northings, or in simple terms we can say x and y. So, these are the geographic coordinates. So, all these three things are important, and for each country there are different projections are available. The best part here is that using computer programs or GIS softwares, we can change our data, our maps from one projection to another quite easily. It is very easy to change one projection data to another with the vector data, but it is rather little difficult relatively with the raster data, but nonetheless the projections can be changed. Another thing is that whenever we go to change in the scale, then the again projection issues might also come there, because if you go for a smaller scale maps, that you are going to cover a large area, and then the curvature of the earth will come, and therefore appropriate projection has to be chosen, because the main aim here, the shape of a country should not change, because if it changes, then your area of that country will also change. Now you know that maps are one type of models or models of reality, which are representing the abstract form of reality, reduced reality. Only selected important features are represented in a map, like a topographic map. So it is having the terrain representation through contour lines or point heights. Then it is having, say, hydrological informations like river network and water bodies. Then you are having a road network. Then you might be having locations of villages, towns and other things. So maps are models of reality or reduced reality, abstract reality, and we try to, as mentioned, that earth, which is a earth as a spheroid, though it is not perfect, but this spheroid is a 3D body. We try to project this 3D into 2D, and when it is done, it has to be done through map projections. And maps, as we know, that these are the basis of any GIS database. Basic 3 types of map projections are there, but then in between there are n number of variants of these basic map projections are there. Like if I use this sheet as a cylinder, make a kind of cylinder and put along the globe, and then glow from inside, the light of source is inside, then whatever the impression it will create on the sheet, photographic sheet, and when I make this sheet flat, then I will see contour lines, and those will be the vertical lines, and the longitude would be vertical lines, latitude would be horizontal lines. If I make that sheet as a cone and then expose, then I would have in the center the longitude would be radiating from the poles, and then I will have circles for the latitude. Again, in azimuth projections, I am not going to say roll the sheet or make a cone or cylinder. Instead, if I keep just flat, then this is how it will be projected. So these are the 3 basic types of map projection exist. Then there are variants, which we will see little later. Now if I bring the boundaries of the different countries or continents along with this map projection, then this is how it happens. See, in case of azimuth projections, when the sheet is not rolled or has taken the shape of the cone, this is what happens. So you know, the countries which are in the center or center of the sheet will have the near true representation, whereas the countries at the corners or margins will have different shapes and therefore different sizes. Similarly here, as you can see, the latitude would appear as a curved lines, and longitude would appear as a radiating line. Lambert, conformal, conic projection, this is how it will look. So depending on the latitude of a country, location of the country in a particular latitude, then the shape would take. Think in a cylindrical projection, when I use that sheet and make as a cylinder, when it is when we flat it in a 2D, then we get these vertical and longitude and horizontal, and a sort of uniform grade is there. But the important point here is to note what happens to the shape of the Antarctica. You know that the shape of Antarctica is not like this. So in cylindrical projection, it is completely distorted. The projection which I have mentioned, the universal transverse Mercator projection, there too you are having this problem, that in the countries which are in the middle latitudes will have a sort of true representation, but the countries at near the poles like Antarctica or North Pole continents will have a completely distorted representation. Similar thing is again shown here, that it depends now, instead of putting and at the fitting at the equator, we can change it, these cylinders. So, instead in a normal position, and this is the one projection, then in this transverse position where it is not kept along with this, and then we can have oblique position. So, all kinds of variations are there. Why variations are there? Because each country on the globe is located uniquely, and therefore, each country would like to have its true shape and size, and therefore, each country has developed their own projection systems. The best part I have already mentioned, that it is good that tools nowadays are available to change from one projection to another. And then there are, as mentioned, that lot of variants are there. You can have a conic tangent, you can have a conic secant, and then these planar planar aspects you can have in azimuthal projections, and then you are stereographic projections are also used in geology, very common in structural geology for southern hemisphere. Also stereographic projections for northern hemisphere are used in mineralogy. So, all these projections are there. Again, in a cylindrical projection, as mentioned, that the continent like Antarctica will have a big problem, same also in the near northern poles, but in middle latitude regions countries will have quite nice representation. Whereas in plane projection, you can see that countries at the near poles, if and the sheet has been kept there, or imagine it has been imagined there, then that will have a true shape and size, but the countries as you go away from the center, then you are having distortions. There are projections which are like a orange, when you peel off, then different layers will come, and that is interrupted projection. So, again here countries which are located in the middle latitude, no problem, but see that what happens to the continent like Antarctica. It has gone in 4 parts. We know that it is a single land mass, and there are problems then in cylindrical projections or universal Mercator, or that projection which I have talked. Now, as mentioned earlier, that projections are used to display locations on curved surface of the earth on a flat sheet according to some set of rules, and these rules are the shape of a region, because we want to keep intact the shape of the country or continent. Then distance between 2 points are also, and then directions bearing from one point to another should not also change, and then if shape has not changed, hopefully the size of the area of the region or a continent or a country will also not change. So, these are the things which are involved, but when we change from one projection to another, there might be lot of changes will occur in these 4 criteria or rules. So, basic principles are there. For many mapping applications, the earth can be assumed to be a perfect sphere. There is a difference between distance around the earth between poles versus the equator, as we know that circumference of the earth is about 1/300th smaller around the poles, and this type of figure is termed an oblate ellipsoid or a spheroid, is the 3-dimensional shape obtained by rotating an ellipse about its shorter axis. An estimate of the earth's surface based on the ellipsoid provides a determination of the elevation of every point on the earth's surface, including sea level, and is often called as datum. So, all these things are important here. As earlier I was mentioned that illumination source is kept in the center, a cylinder shaped paper is set here, and when you exposed, nowadays mathematically you do not have to do it physically, mathematically using softwares, all these things can be done. Most of the GIS, good GIS softwares are capable of changing data from one projection to another, and also if you are having basic information, basic parameters available to you, you too can create your own custom design projection to represent a particular country or landmass in its true shape and size. So, projection as is a representation of the earth 3D into a 2D, and a projection of an image into another surface, either a cylinder, flat plane or cone. These are the basic types which we have already discussed this one. And now what we want to keep. If we want to keep equal area, then emphasis on the area will be intact, but there might be some other distortions will come. So this is how we will go one by one, that equal area correctly represent area sizes of the sphere on the map. Universal UTM projection or universal transverse Mercator projection sometimes is also called equal area projection. So each cell of that grid of latitude longitude represents the equal area of the earth's surface. But as mentioned that on the poles the continents or countries gets distorted. In the central mid latitude region things are more or less in order. So that is another very popular one. Lambert cylindrical equal area projections are there. Your universal transverse projection is also equal area projection. Then instead of equal area you can have equidistance that correctly represent distances between 2 points, and example is here is the plate carré projection or conformal projection that represents angles and shapes correctly at infinitely small locations. So various emphasis have been given whether you want to keep area intact or distance intact or intact with the angle and shape. So if shape is also intact, the country will also most likely to have a equal area, the area intact. And the example in case of conformal is the Mercator projection. Universal UTM is a mix up of equal area as well as conformal, and so that is why it is called universal Mercator transverse projection. There are other issues are here that the cylindrical or conformal projection preserves right angles between lines of latitude and longitude and are primarily used to because they preserve direction. So if you are having all cells are representing as a rectangle and your longitude are vertical, your latitude are perfectly horizontal, then you can have this right angle preservation, and therefore you preserve or your direction, that is say north direction, east, west, south, all is preserved or remain intact in cylindrical projection. Area is always distorted on cylindrical projection. Example is of Antarctica. Cylindrical projection that a sphere into a cylindrical tangent to a central meridian, and meridians and parallels intersect at right angles, that you can see here. So it depends on where exactly the cylinder has been assumed in this mathematical model. Mercator projection or also called conformal projections, this is how see the distortions which are occurring to the Antarctica, but other countries are. In order to represent the true shape of Antarctica, it is better to have planar, conformal or polar projections. We also call them polar projections, and when we assume that the seat is kept at the say southern pole, and when light is projected through the grid, then the true shape of Antarctica will come. So whenever Antarctica is shown in some map, they use the polar projection, in which in polar projection the longitude will radiate from the center of Antarctica and latitude will have a circular shape, which preserves the angles. Mercator projection distort scales, and once the scale is distorted, your distance, direction and area too is distorted. So depending on where the country is located, appropriate projection has to be chosen. Distortions increase away from the central meridian, as you can realize that the near poles things would be better, and used in sailing direction more important than distance. So maybe in navigation and water navigation or sea navigation they prefer, because they want to keep the direction intact. Now in conical projections or also equal area projections preserve the property of the area, On an equivalent projection, all parts of the earth's surface are shown with the correct area, and latitudinal distance are never accurate. So, this having problem with conical projections. Examples are here, and that why these complications are there with conical projections. And then there are when we fix certain standard parallels, and with two parallels example is given here, then this is called Alber's equal area conical projection. Now, as I have said that it is need not to be that the cone of that paper has to be near the poles. You can make oblique projections, and depending on again requirement, and therefore things would be different. And this is which this Alber's equal area projection, conical projection will distort scale and distance except along standard parallels. So, between two parallels which a user can give as per the location of the country, between two parallels these things can remain intact, but other things will get distorted. In azimuthal projections, when you keep the seat as flat, and wherever you want you can touch if it is physical model, or in mathematical models accordingly you can assume. In azimuthal projection only preserves correct distance relationship along a few lines on the map, and there can be two major types in planar projection or azimuthal projections, that you can have second, that means instead of assuming a tangent, touching tangent at the poles, you can assume something like this as well. So, again depending where you assume where is the country located, accordingly going for true shape and size, and then may be suitable for particular country, may not be suitable for other countries. Now, planar or azimuth projections, where as I have said that we assume a flat sheet is located in contact with the globe and points are projected from globe to the sheet. So, then the points are projected, and then your 3D surface may become 2D through this projection. So, this brings to end of this presentation. As I have already mentioned, 3-4 things why projection is required, because instead of a 3D earth we want to represent in form of maps, and therefore we want to project into 2D. Now, each country is located uniquely on the globe, and therefore everyone would like to represent its true shape and size, and when it is intended, then everyone will go for their own projection. However, the important point which I have also mentioned, that it is good nowadays mathematical models are available, those have been implemented into GIS. All modern GIS software supports transforming from one projection to another. Transforming projection from one to another with vector data is rather easier, however with the raster data it is difficult. So, thank you very much.